good morning, good evening, wherever you are on this planet, and welcome to the already the third Swift server meeting. As I'm speaking, I'm trying to share my screen as well, because we have prepared just a few slides to get started with the agenda. And here it is, and we should be able to bring that back. Hey, here I am. So this is the third Swift server meetup. This time we decided to organize that at an APG-friendly time zone. So if you are in Japan, in Australia, thank you for watching. If you are in Europe, it's the morning for you. Good morning, folks. And I guess nobody from the US will join because it's the night still in most part over there. Thank you, Janice, for being there as well. So we have a nice agenda today. We have Yuta Saito, a software engineer, that will show us how we can run WebAssembly on Swift. And then we will have an update on Swift 6
on WebAssembly, right?
by Conrad, correct. And just like we do usually at the end of this meetup, we will have a generic Q&A question. So if you have questions about Swift, do not hesitate. Swift on the server, do not hesitate to ask your question. You can ask questions in the comments of YouTube. I see that a few of you are already there, so thank you for joining us there. Do not hesitate to share a hello and tell us in which city you are or in which country you are, so we can see the audience, where the audience is coming from. And Joannis is on holiday in Greece with blue sky.
It was raining here just a second ago. I'm lucky now.
Before getting started, maybe you noticed yesterday night was update night from Apple. So macOS Sequoia is available as a download. iOS 16, iPadOS is available as well. Xcode is there, the new version of Xcode 16, and most importantly, part of Xcode, but also available as a separate package to download for Linux, the general the GA version of Swift 6 is there. Yeah, that's super exciting because we were waiting for that since quite a long time, Janice.
And alongside Swift 6, we've got a lot more coming up because the ecosystem has not been idle. Ever since Swift 6 was announced, or even in the early stages of Swift 6, of course, Hummingbird has been in development. And alongside Swift 6, we've also released Hummingbird 2. But we've got even more news because just as Swift 6 released, Tim Condon from the Vapor core team has started development on Vapor 5. So there's a lot to be excited about coming up on server-side Swift.
And in the Swift forum, Tim posted a long message with the principle and the guidelines and the design for Vapor 5. So if you are using Vapor, have a look at that document. It's really the roadmap, like the direction for the next few years for Vapor. It's quite exciting to see the change that are coming. Talking about things that are coming as well, next week, end of next week, it's Thursday and Friday next week, if I'm correct. In London, there is a server-side Swift conference that is organized, and you can get, if you don't have your ticket yet, you can get a discount, 15% discount with the SSWG Meetup code. And that discount is only valid for the next 2 days. So if you're watching this video in a couple of weeks, don't try to get your ticket. It's until September 19, and the conference is next week. September 26 and 27 in London, and the team told us that there are still a few tickets available, so do not hesitate to join us in London. I guess most of the team will be there. You will be there, Janice?
I'll be there, and I've seen the lineup of speakers. You can see it as well on the website right now. It's looking astonishing. There will be great talks. There are always great talks on the conference, but this year is going to blow the rest out of the water.
And I'm really looking forward to meeting the different members of the community next week in London. That's all for us. The core of this meetup is about WebAssembly and a short talk about Swift 6. So we have the pleasure to welcome Yuta Saito. You're based in Japan. Thank you for joining us today for the third Swift server meetup. And the stage is yours.
Okay, thank you for coordinating this meetup, and hello everyone, and thank you for joining us today. And I'm excited to talk about WebAssembly support in Swift. And yep, and I will today I will share you how it's evolved over the years, and now I will share that now Swift developers can leverage it to build powerful app that runs in browser or even outside of the browsers. So today I will guide you through the Swift on WebAssembly, show you how to use it, and demonstrate some use cases. So first, let me introduce myself. I'm Yuta Saito, master student from Tokyo, Japan, and I'm a newbie committer of C Ruby and Swift language, and working on WebAssembly support for both languages. So now let's talk about WebAssembly and what it brings to the table. Oh, I need to something to show some what? Okay, it's okay. Okay, let's continue. So, next, let me briefly explain the concept of the WebAssembly itself. So, the WebAssembly is a binary program format compiled from various languages, including Swift. And WebAssembly is designed to be portable, secure, and embeddable, and also deterministic. So the security is achieved by virtualizations, and it means WebAssembly process is always executed in isolated domains, and it does not allow any system calls by default, and all interaction with the system can be controlled at user end. So this is important because we don't need anything about the kernel dependent stuff to control the system calls. So it's well similar to sandboxing on Darwin or seccomp or Docker in Linux. But WebAssembly is portable across platforms, and thanks to the virtual program format layer, it's completely independent from the platforms. So Wasm has a lot of potential as a program format for sharing programs, not just for web browsers. So for example, from the perspective of the program language, if you can compile your language to Wasm, your program can run in all kinds of environments, whether it's on an ARM processor or x64 or even bare metal system. So on the other hand, from the platform's perspective, if it supports Wasm as a program format, it can indirectly support many different languages. So that's why I think just like JSON has become the default standard for exchanging data, Wasm could become the default standard for sharing program, I think. So despite its name, those properties are also helpful outside of the web. And the some of the common serverless platforms, they usually provide container-based solutions to deploy their customers' applications. However, recently, some of the cloud vendors started providing WebAssembly-based solutions, and WebAssembly has very similar properties with container, but it's more lightweight and easier to maintain. A typical container-based isolation requires communicating with host kernel, but WebAssembly isolation can be implemented fully in user space, even within a single host process. Okay, so WebAssembly is a cool technology. Why not support it in Swift? So the Swift Wasm project is a community-driven effort to make Swift to be WebAssembly friendly. And it provides a collection of products related to Wasm and Swift. The main components we provide now are these three. The first one is a Swift SDK for WebAssembly. The SDK is a set of precompiled libraries for WebAssembly, including standard library, foundations, XCTest, and so on. And we had been maintaining several patches on top of the upstream Swift repository. However, last year, we have upstreamed all the changes against the Swift compiler, LLVM, and standard library. And also, the target is continuously tested in the upstream CI. So most of the work currently is currently done in the upstream repositories, and the only stuff left in the Swift Wasm project is just building the SDK and distributing it and providing several tooling and libraries. The second component is a JavaScript interoperability library named JavaScript Kit. The JavaScript Kit is designed to be available for all JavaScript to unlock communicating with JavaScript from the Swift side. And I will show you the example later. And the last one, Carton, is a build tools to make the daily workflow for developing web applications, web client applications in Swift. And I will show you it too later. Yes, so I introduced the project itself, but is it used in serious productions? Yes, the Swift Wasm project is the Swift Wasm project provides everything you need to run Swift on WebAssembly, and it's already used in some of the production applications. The first one is a Good Note Web, which is a part of the note-taking app popular in the Apple platforms, and it's ported to web platform by using Swift Wasm toolchain and also combining it with React.js. So it's successfully ported their app with reusing their most of the code base and provides a web native experience with React. So we can use our toolchain in a hybrid way like this. You can check more information in the blog post. And also, there are another serious application, Floki, which is piano lesson applications, and also it's also ported from the iPad applications to web. Yes, so and they said they successfully reuse most of the 100% of the core logic from their app. So yes, that is a successful story of Swift Wasm in productions. And why we build web app using Swift? It's just for fun, yes, of course, but it's not the only case. The major motivation to build web app using Swift is to share client logics across platforms. For example, GoodNotes successfully reused more than 100,000 lines of code in their code base, and it saved us it saved their effort for reinventing everything in platform specific way, but reuse their existing code base as much as possible. So okay, so okay, so it's well production ready quality, and we have motivation to use it. So let's start building web app using using the toolchain. So you can develop your web application using as a Swift PM package, and you can create a new package using a package init and add the carton build tools as a dependency, and then you can start the application just one command, Swift run carton dev. Then the dev server started like this. So in this example, you can see the source code in the Chrome DevTools. It shows the original source code in the DevTools, and you can see the console, the print output in the developer tools console. So yes, that's a way to build the web app in Swift. But yes, I know you are most of you curious about how to interact with DOM. Yes, Swift Wasm toolchain provide a way to interact with JavaScript world without any hassle. You can just add a JavaScript interrupt library, JavaScript kit, into your package, and Swift package, and then add the package as a dependency to the target. Then you can write a piece of Swift code to interact with JavaScript world. This is it might see like a magic, but it's built on the top of the dynamic member lookup, so you can use any JavaScript feature from the Swift side. So the first line, document let document JS object dot global dot document, it is equivalent to the writing a document in JavaScript words. And also you can call any method from the document object. So you can create paragraph element from Swift, and you can set the property of the of the paragraph element. Then you can append it into the body. Then you can see the result like this. Cool. So in this way, we can create web application using Swift without any hassle, with leveraging the JavaScript feature and also reusing the existing code base in Swift. But it might be too much for you, and if you want to learn more about the internal stuff and want more minimalistic example, you can learn more about in the talk given by the Max Deserto in the Wasm IO, and you can run more low-level stuff and more how to produce a kilobyte WebAssembly binary using embedded Swift and WebAssembly. So yeah, that might be interesting for you too. So this is I show the basic example of the how to use Swift on WebAssembly and how to build the web application on top of the toolchain. And there are several resources online. And the first one is Swift Wasm book, is maintained by Swift Wasm team, and gives you a basic overview of the toolchain, example, and some of the internal stuff. And the second one is a collection of example, great example shared by Steven. And yes, it's quite helpful to run by example. So, and the third one is you may know the Point Free. Recently, Point Free shares their episode about the WebAssembly on Swift and how to make the cross-platform libraries and application using and port their application to WebAssembly. So it might be interesting for you. The last one is a library to create a rich UI application with a similar concept of React.js in Swift. So it's still experimental, but yes, it's quite interesting project and worth to see that, try that. Okay, so I showed how to run Swift on WebAssembly platforms, and good. But recently, we had been working on additional friendship with WebAssembly, so it's still continue. The second part of this talk is the other side, running WebAssembly with Swift. So I shared the slide before and introduced the three components: SDK, JavaScript kit, and carton. But to open the new possibilities, we added a new component, Wasm kit. Yes, you might think it was the end, but still continue. So the new component, Wasm kit, is a runtime, a reasonably fast WebAssembly interpreter written in Swift, written in pure Swift, nothing written in Rust. So you can use it as a Swift package, and it has minimal dependencies. The core runtime engine only depends on Swift systems, so no other dependencies, and also it even does not depends on foundations, so it's easier to port other platforms even without foundations. And the implementation is well compact and embeddable to applications, and the runtime is can be built within 5 seconds. And also, the package provides not only the runtime implementations, but also some of the essential part of the WebAssembly ecosystem, like WASI, which is a WASI system call interface, and WasmKit provides the implementation of the interface, so you can run any programs, WebAssembly programs that compatible with WASI on WasmKit. So of course, the Swift toolchain produces a WebAssembly program with WASI compatibility, so you can run Swift on WasmKit, of course. And also recently we added a WebAssembly text format parser, and so you can start without any tool chain. So yes, it's well batteries included. So what does it mean adding a WebAssembly runtime in Swift ecosystem is that so for now, from now, we had the Swift as a as a as a source language of the WebAssembly, and however, the runtime implementation was only limited to the web browser or Wasm time, which is written in Rust language, so it's not easy to integrate with Swift app. And also there is several implementation like Wasm micro runtime, which is targeting the embedded systems. However, yes, of course, it's not easy to integrate. So with what WasmKit fills the place at the runtime, so you can run the WebAssembly programs compiled from any language on Swift. So you can compile, so you can accept WebAssembly programs compiled from C or Go or Rust, any language, and run it on your applications. So let me share the how to embed Wasm runtime to your app. So the Wasm runtime, the input of the Wasm runtime is a Wasm program, and it can be compiled from any language, as I said. And also there is a text format of the program, and WasmKit provides a text format to binary format translations, and you can write you can convert a WAT file to Wasm binary, then pass it like this. Then you can define a host functions that can be called from the Wasm program, and the host function here prints the i32 value, integer value given by the guest programs. Then inject it to the expose the feature to the runtime. Then instantiate the program module program. Then call the functions exported by exported from the guest programs. So in this way, you can embed the WebAssembly runtime to your app and accept any programs in a safe way without worrying about the security stuff and execute it in an isolated environment. Some of the showcase that uses the Wasm kit is a distributed plugin actor system. So the repository Swift subprocess distributed actor shows an example to use a Wasm kit as a distributed actor system. So distributed actor offers a way to interact with actors without sharing memory space. So it's usually done by the communication across the over the network or across a process by inter-process communications, but it can be achieved achieved within a process by using a Wasm kit. So if the plugin authors provides a Wasm plugin that implements the greater distributed actor protocol, and then host program accepts those plugins, then call the greater grid through the distributed actor system. Then then you can build a plugin system in a platform independent way, and in this way you don't need to worry about any platform specific plugin system like dynamic library loading, DL open, ABI compatibility, or like that. So what you can focus on building your plugin system in a platform independent way using WasmKit. This is just an example, but I think it might be useful for some of the tool authors in Swift ecosystems. So yes, it's a similar but and still ongoing work, but we have been working on the speeding up the Swift macro build by utilizing the portability of Wasm. So Wasm is a platform independent format and portable across the machines. So you can share the precompiled Wasm into the other machine, and also it can be run without modifying anything on other machine. So the idea here, and the problem in the Swift macro is the long build of the Swift syntax, and it slows down the entire build pipeline of your app. So the straightforward idea is just to precompile the macro plugin and distribute it as a binary. However, distributing a binary is not a portable way, and if you need to support platforms more like Windows, Linux, and other platforms. So in that case, so you cannot share the binary, precompiled binary across platforms. So here is a WebAssembly fit in this use case. So the idea is precompile Swift macro into .wasm binary and using the Swift SDK for WebAssembly. Then distribute the binary .wasm macros. Then evaluate the macros without building themselves at build time. And the evaluation is going to be powered by the Wasm kit. And so, yes, this is the idea, and it might be it might help your build time in the near future. So yes, still it's not the this is not still not merged, and there's no concrete timeline to provide this feature, but it might be a promising approach. So conclusions. So now WebAssembly support in Swift evolves year and year, and now it powers some of the serious production applications. So you can try it. And also, Swift Wasm project offers the other side, running WebAssembly in Swift, and the runtime Wasm kit offers an easy way to execute WebAssembly in your applications. So yeah, I hope you will try it in your applications, or I will happy to hear your feedback. Thank you.
Wow,
No,
Yuta, you blew away the audience, and at least us within the Swift server working group, we were chatting during your talk, and wow, it's mind blowing, and it opens so many possibilities. We have a couple of questions. Maybe Johannes, because you have the mic, you had a couple of questions as well. Maybe you can start, and then I will select questions from the comments. So I will put the comments on the screen. We can read the questions together. If you have questions, feel free to add them in the comment, and we will answer them one by one with Yuta in a minute. Johannes.
So my first couple questions, I believe, were already answered. The first one was, does the Swift WebAssembly SDK get packaged as a Swift Package Manager SDK, or is it like a separate toolchain still? I know that SDKs are their own toolchain, but does it use the new SDK infrastructure?
So the SDK is currently is a form of the Swift SDK implemented in the Swift PM, and it was proposed in the Swift evolutions and accepted in the formal way. And yes, the feature is yes, so it's like a static Linux SDK, and you can install it as a Swift SDK, a Swift SDK install or something like that. But it's still distributed under the Swift version organizations, so not distributed under the Swift.org.
Yes.
Yeah.
That's perfect. That sounds awesome.
And we learn a new comment on the package, Swift SPM package for Swift 6. We saw in your example that now we can type Swift package add dependency or add target dependency. I didn't know that, and it's in Swift 6. If you wonder where is this coming from, that's from Swift 6.
Yes, this is very, very useful to show this kind of the examples.
Yeah, it will make all tutorials and documentation much easier. We don't have to show the package.swift file anymore. That's great. A question from Dave. Does the JavaScript kit have a broad coverage of DOM methods, or is it a subset?
Oh, so Okay, so this is not the JavaScript kit does not know about the DOM method and any web API. So it can it seems like there the JS object provides DOM properties, but it does not because it just provides a dynamic member lookup subscript. So you can write any property here, and so you can use any DOM API, not subset.
And that was the answer also provided by Stephen. Hello, Stephen. That it used dynamic member lookup. It's just not dynamic, statically typed, of course.
Right.
What other questions we have? So we have a lot of good comments about the work done. I show a few of them on the screen. Amazing session and insight on Wasm tooling. There's a last one. Binaries are powerful, and I'm wondering where is Swift server side it could land, or in the nearest feature. That's a good question.
I might not get it. So what do you mean where? I'm wondering where in the system.
The way I understand the question, Jalil, tell us if it is correct. Is can this package and SDK join the Swift server side? That's the way I understand it. You too, Johannes?
Yeah, basically how I understand it indeed is, where does this fit in the server-side Swift ecosystem?
I not actually don't know the the plan, but yes, the plugin stuff is plugin use case might be useful for on the server side because so usually we accept JSON as a server input from the API, but what about accepting a Wasm file as a user input? In this case, we can implement not data but the program as an input and allow user to customize their behavior in a limited way, in a secure way. So yeah, that might be interesting for server-side workload.
Yeah, I can imagine when you're building something like a CMS.
Right. Yes.
Yeah, you want to explore the plugin architecture without compromising your cloud services.
Exactly.
There are also a couple of serverless runtime environments, like the one provided by Cloudflare, for example, the Cloudflare functions that accept a Wasm runtime. So I guess that would be a way to run Swift on the Cloudflare function.
Exactly.
Maybe that's a question for you, Yuta. What's the general compatibility with the Wasm runtime? Once it's compiled for Wasm, it should run on any Wasm compliant runtime. That's the promise.
Yes, as long as the binary and the runtime implements the same set of the WASI system calls, they are all compatible and portable across the runtime and platforms.
Okay.
Yeah.
Another question from Jalil about the status of threads and concurrency.
Good questions. So basically, we have two targets: the one without threads and with thread. The reason is that there is ongoing work that standardizes the thread specification in WASI system calls. However, it's still under development and going to be replaced. It might be going to be replaced in better solutions. So we currently have two different targets. So, and with the thread supported target, you can use a thread as you think, and you can utilize the web worker in browser as a thread. From the perspective of the Swift, a thread correspond to a web worker, and you can offload heavy workload to the worker. And especially for concurrency, the concurrency does not require any thread actually. So it can be run without thread, but it can run even with single thread. So the Swift concurrency is supported in the both with and without threads targets. So yes, Swift concurrency is fully supported on these platforms.
Thank you. I'm curious. So, question from Aki. I'm curious how Wasm help merging codebase of Android of good nodes as a practical example. Are there any example projects?
So basically, the idea of the reusing codebase across platform is splitting the core logic, not UI stuff, but the domain-specific logic into a separate package. And we have dozens of Swift packages inside the in a mono repo. And yes, so that is the basic idea. And as you know, we can utilize the dependency injection or something like techniques to inject the platform-specific stuff into the deeper packages without sacrificing the portability. So that's the basic idea. But we don't have any practical example in online. So yes, you can create it.
Thank you. And Johnny, you have a question as well? You can read
Two
it.
actually. So does WasmKit support embedded Swift?
So I haven't tried it, but in theory, it's not so hard to port the runtime itself to embedded Swift, because we have no foundations dependency and have a limited allocations, and yes, so that should be not too hard.
Cool. And what's the performance of the runtime like right now? I'm not sure if there are benchmarks or comparisons to other runtimes.
Good questions. So we intentionally decided to go interpreter way, not in just in compilation or something like more exotic way, but yes. So comparing with some of the compilation runtime, like Wasm time, the peak performance is not good, is worse than it. However, the startup time of the Wasm kit is now better than the Wasm time. And also the interpreter itself is well optimized, and we have utilizing traditional interpreter or virtual machine techniques like direct threaded code, and also the Wasm itself is a stack machine. However, for the performance reasons, we have internally translate the bytecode into the register machine, and it saves the performance for about 4 times faster. So yes, the interpreter is well fast, but it's compatible with other runtimes implemented as an interpreter, right? Even with other language like C or Rust.
Thank you.
Two more and last question. One from IODG. I hope I pronounce your name correctly. Is there an active community around Swift on WebAssembly? How can we encourage developers to get involved in the community?
So most of the work is done within the Swift Wasm project, and there is a so I will put a link later, but you can access the organization web page by the yes. So and there is a Discord community talking about the WebAssembly support, how to use Swift on WebAssembly, and like that. So yes, join us.
Please join the community. And joining a community is not only about writing code, helping writing documentation, bug report. It's also super useful. So even if you are not a coder or don't define yourself as a coder, please use and report the issues you might have. Last question from iOS chain. Have you ever used in some use case JavaScript kit for WebAssembly plus Vapor on the server? And is there any pro and cons about this type of architecture?
I haven't mixed those two. So to be honest, I don't have any idea on that.
So we have Steven that answered the question. He says that he experimented with that, but wouldn't recommend it. In the end, using JavaScript kit is just like writing JavaScript, but without IDE support.
Yeah, I agree that.
So thank you very much, Yuta, for your presentation and your demo. That was very impressive and a good way to. It gives me a desire on V to get started and to try Wasm with Swift, and I hope it gave the same effect to all of you that attended this meeting. I will also add all the links from your last slide to the YouTube description. So send me the links, and I will copy paste that to the YouTube description just after this. Thank you so much, Yuta, for this talk. Second talk of this third meetup. It's a short update on Swift 6, and it's just in time because it was released yesterday night my time. Maybe it was a bit later or sooner for you. And our second guest today is Conrad. Conrad, you're part of the Swift server side member group. You're working for Apple, but I will let you introduce you by yourself. I see that you're sharing your screen, and I will send your screen there. Thank you, Conrad, for being there. The stage is yours.
Thank you, everybody. Okay, I hope you can see the right screen. Can you just confirm? Full slide.
Get ready for Swift 6 if it is your screen. Then we see the right one.
Okay, cool. Okay, thank you very much. Thanks for having me. Yes, Sebastian introduced me. I'm part of a server work group, also part of a Swift team. Primarily, my focus there is Swift concurrency runtime. So sometimes also a bit of compile time things, but primarily runtime, distributed actors, and also server libraries, which is why I'm part of a work group. And today we're kind of celebrating really the release of Swift 6.0. And this talk is a brief run through. So this won't cover everything that's in Swift 6, but I thought, hey, here's a few tips I can share. So as we just said, 6.0 just got released, and that's a perfect time to give it a go if you haven't already been checking out the betas. So go ahead, download it, check it out. And Docker images, everything should be coming very soon. So steps for adopting Swift 6. Really, the first step is to not panic. Sometimes I see people get really worried that, I can't, spend the time on updating all of my libraries to Swift 6 right now because it's, coming with more static checking and more safety, but I don't really have time for that right now. The good news is you don't need to worry about that because you can migrate at your own pace. Swift 6 is, of course, it's the new language features that come with new distribution. It's also library features, but the Swift 6 language mode is something that you actually enable yourself module by module, and you can really do it whenever you feel ready to do so. So you don't need to hesitate with downloading the latest toolchains and checking them out. So yeah, that's that. I touched a little bit on it already, but Swift 6 language mode is opt-in. So you can enable it whenever you want, whenever you feel ready to do so. And you can use the latest compilers and everything, or the library features, still in Swift 5 mode, without the complete static checking that attempts to prevent data races. So Swift 6 language mode really is all about the data race safety. It enables a lot of static checking, a lot of the checks you may have seen before in 5 mode, but maybe they were warnings, or maybe they weren't, as comprehensive as in Swift 6 mode. And it also enables a bunch of dynamic checks whenever we have a situation where static checks are literally not able to check something. Usually this is on interop layers, for example, interoperating with Objective-C, or whenever you have some pre-concurrency libraries that cannot guarantee safety. A Swift 6 module would sometimes enable dynamic checks to prevent you from accidentally breaking invariants you may have been relying on. So how do you enable Swift 6? There's a few ways. In server libraries, the one you will probably be using the most is just in Swift package, updating your Swift tools version, usually first line in your package Swift. If you change that to Swift 6.0, you will be automatically giving all the targets in that package file, in that package, the Swift 0 mode. Then you can override in specific targets. You can say, hey, for this one, I still want 5.0 mode. And you can also put it on a package-wide one setting and just have it apply everywhere. If you're using Xcode, in Xcode projects, you can go into Swift compiler -language and change the Swift version there. It's going to be by default Swift 5. So even if you create a new project using the latest Xcode, you still have to go there and enable Swift 6 mode, right? So remember that. If you're not seeing some of the warnings you're expecting, maybe you're not in Swift 6 mode. I said that before, but it's not only your targets that you can really selectively update to Swift 6, but it's also your dependencies. So really, of course, it's the best the more libraries update to Swift 6 and get complete checking, but it's not a requirement, for example, for your target to be already in Swift 6 mode, even though some of your dependencies are not yet enabling this mode. Maybe some of them have, some of them haven't. So it's a really fluid process that will, over time, or the next few months or so, we will be seeing more and more libraries adopt Swift 6. So how does Swift achieve data race safety? Primarily, it's really about two related concepts. It's actor and region isolation, which determine where a value is kind of stored and where a piece of code executes, and then checking of sendability. So sendable values are safe to cross isolation boundaries, and sometimes even not sendable values are safe to cross these isolation boundaries, but we'll talk about that later. So these two things combined together guarantee you safety from low-level data races. And if you don't remember anything else from this talk, I want you to remember this link. Because as you're going to be migrating to Swift 6, you may face pretty common situations or common patterns that may help you out, that have solutions, basically. And I would really recommend you checking out the Swift.org migration page. We worked on that recently, really to help you out. Whenever you see a problem maybe you don't fully understand with concurrency checking, this is probably the best resource to reach out from too. Not only that, it's very easy to open questions and contribute. It's just a GitHub repo where we collaborate. So if you have questions or would like to add some content here because you think, hey, this is a thing I commonly stumble upon, this would be fantastic as well. So as the community grows and moves more towards Swift 6, we can keep improving this content as well. So what really changed in Swift 6? Swift 6 accepted 32 proposals in total, but only 12 of them are strictly concurrency related. Some of them are just library and runtime things, so it's not like 12 huge proposals were accepted, but you can separate them into a few categories. Primarily, we're really interested in the safety checking model because the new region isolation checking is really going to give you the most flexibility that you didn't have in Swift 5. And then there's more execution semantics control proposals, which allow you to have more control over where things are executed, both dynamically and statically. And a few more. I'll talk about them, and I'll select a few and talk about them in depth. So most importantly, static checking. So those are the proposals you may want to check out later on. Those are really compile time checks that will prevent you from errors that will definitely cause data races if they won't get fixed, right? So this is static checking. Then we have dynamic checking and runtime execution semantics improvements. For example, task executor preferences. We don't specifically change isolation or checking. However, they are very interesting for performance tuning. So this is something that might be quite interesting for you. And custom isolation checking for serial executors made the dynamic checks we sometimes have to insert using assume isolated, precondition isolated. They make them more correct. In Swift 5 mode, we had edge cases where we would fail, but actually, if we tried harder, we could detect that it's actually safe to do and assume here. Okay. Now, if you're absolutely new to Swift concurrency, you haven't written any Swift concurrency at all, or maybe you just haven't dug deep into it, I would really recommend those few talks from WWDC. There's one per 1 year of WWDC that I selected. And by checking out those, I think you'll be well set up for the Swift 6 migration. They're pretty fun as well, so if you haven't seen them already, that's what I would recommend. Now, let's jump into the hints section. And I just want to highlight a few of the proposals and changes in the language and how they affect you and help you out in using concurrency in Swift 6. Okay. So the first one is related to region isolation, and the common scenario that you may have stumbled upon in the past is when you have a non-sendable value, but for some reason is not thread safe. It cannot be used from multiple threads at the same time. Here we have a client type that's not sendable, as you can see. It's a reference type. For some reason, it can't be made sendable. Now, in the past, if you created such a value and then passed it along to an actor, so client store shared, that's an instance of an actor, this is crossing an isolation boundary from the main actor here, open account as main actor, and then to the client store shared actor. Because this is crossing an isolation boundary, before Swift 6, we would say, hey, passing this non-isolated value risks data races. And that is true, because now both of this main actor and the client store actor may be accessing this type concurrently. So, this is true, but in Swift 6 and region analysis, you can check out the proposal below, we actually can use a flow-sensitive analysis and check out that, okay, we're creating this client value, we're passing it to this other actor, okay, it's not sendable, but we never use it again in this main actor. Right? So the only purpose of sendability and all of these checks is to prevent concurrent accesses. So because there are no more accesses here and we're not escaping the client anywhere, this is actually safe because we just moved it along to the other actor, which can now semantically own it, and that's the only place where it can be modified. So that's a fantastic change. It allows you to really work with types that aren't sendable, but in situations where you send them from one user to another. That's a big change. Now, this doesn't necessarily just work out of the box when you have more methods in play. In this example, we have a local variable. We pass it along somewhere, and the compiler has holistic knowledge of, okay, this truly hasn't escaped anywhere. I can prove that this is correct. Another situation is when you were to write let's say you have a try send method, it accepts a non-sendable value. And then we want to do basically the same thing. We want to pass it along to another actor, here to the main actor from a non-isolated async function. Again, before, this would correctly be flagged as an error because, again, we don't know if this non-sendable value isn't kept somewhere else, right? Maybe it's kept by another actor. It was passed to this try send, and now we would pass it along to another, again, causing potential races. This would be bad. And just from this method signature, the compiler can't really prove that, okay, we don't know if this is safe or not. It might be. So in order to help out the compiler and yourself, getting these patterns correct, you can annotate parameters and return types as well, actually, with new sending keyword. And the sending keyword, it's related to the sendable protocol conformance, but you see it's on a specific use, on a specific parameter. So we're saying whenever this non-sendable value is sent into this try send, we transferred the ownership of it, basically, and it can be passed along to another concurrency domain. So again, by adding sending, you can work with non-sendable types in a lot more context than you could before. Really something to keep in mind if you have to use non-sendable types for some reason. And again, also works on return types. If you return something that you can want the receiver to take concurrency ownership of. A few more hints for using legacy code. And I believe the first one is more relevant for us in server systems, which is just using pre-concurrency import on a library, which effectively means I know that this library hasn't annotated itself using proper sendability. So please downgrade some of the warnings and errors because I still have to be able to use it. Maybe it has some guarantees, but it just hasn't expressed them with sendability. So this is a popular thing to do, has been around since Swift 5.6, and again, still very valid to use. Another one that is new in Swift 6 and may not be as interesting for us in server systems is pre-concurrency conformances. That is new in Swift 6. However, it applies to a different scenario. It applies to a situation where you have a protocol, and that protocol has a synchronous requirement, but for some reason, you know that this will always be called on the concrete context of some actor. It usually shows up in UI systems, which we don't really deal with on the server, where libraries guarantee that you will be called on some specific actor, usually the main actor. So pre-concurrency conformances allow you to conform to a synchronous protocol requirement, and then using other means, you have to guarantee that it will be called in the right context. You should then do a precondition isolated that it actually was called in the right context. But yeah, it's a powerful thing if you need to integrate with a legacy API that just hasn't adopted concurrency at all. Again, in server-side systems, I think we moved along a bit faster than other ecosystems, and we have a lot of async adoption already. So maybe this isn't the big problem for us, but new tool available for you in Swift 6. And one thing I do want to highlight, because I've seen sometimes people be unclear about, or even as you write your own libraries and you make some type not sendable, you just don't annotate it with sendable. And you as the library author, okay, like this type is really not sendable because something. And maybe you've even documented it somewhere, right? I would strongly recommend doing it explicitly. When you have a type that really is not sendable for some reason, you should write this unavailable sendable conformance. This is basically saying this type is definitely not sendable, but you express it in source code. So it's easier to discover, and when someone uses your library, they can see, oh, okay, it's not a mistake that this type isn't annotated sendable, it's intentional. So I highly recommend doing that for some types where you make a specific decision to make something not sendable, and you don't intend on ever making it, for example. So I recommend doing that. The spelling is, as you can see here, just unavailable conformance. Okay, here's a tip about, not about isolation per se, but about influencing where tasks execute. So you can change the runtime semantics of the exact threading or executors used to run some asynchronous code without affecting the isolation semantics. So all the isolation semantics you know from actors and sendable checking are all the same. However, you can change where, what executor something executes. Why would you want to do that? Well, especially in server systems, I think we care a lot about reducing context switching. And by using a executor preference on a task or on a block of code, which I'll show later, you can really say, okay, as much as possible, try to be sticky to this executor that I prefer over here. So in my example here, I have a capybara actor, there's a function eat, and you see normally this would imply hopping over to the actor and hopping back from it. There's situation where this is optimized away, of course, but semantically, that's what it means. And with a task executor preference, we're basically able to say, okay, I'm running this task on this executor. This actor doesn't have a specific executor preference. It doesn't require some specific custom executor. It's not the main actor, right? But I can say, I really prefer if it would run on this executor. So by doing this, you can avoid context switching. This can really add up and help you in some hot paths where you have code that really should be using the same event loop or the same thread all the way through. So remember that when you're doing some performance tuning, maybe. The other way to use this is with non-isolated functions or also async let. And task groups have also a version of expressing this. And this way you can annotate a block of code. This will jump to this some executor, and all of the child tasks, including the async let over here, including the non-isolated async function, they all run on this some executor that we provided here, which is, again, not typical, because normally an async let would always execute on the global pool, and a non-isolated function would always, a non-isolated asynchronous function, I should say, would always execute on the global pool as well. So again, you get much more control, and you can fine-tune runtime behavior. Keep that in mind as you profile and tune your systems. Last hint that I have about synchronization techniques, and I think it's an interesting one because we need to break away from past patterns a little bit. So in the past, you may have written code that's like this. So there's some non-sendable state, here's some function change, it will mutate the state. Okay, it's a typical non-sendable example. And then you put it in some other class that you have to make sendable for some reason, right? So you have var state, doesn't really have to be var in this case, but you will be mutating it from something that has to be sendable. Now, one way to change that to be correct is to make this container type an actor. All actors are sendable. They guarantee unique, non-concurrent execution. So that's a great way to do it. It's very easy. And sometimes it's viable. The only downside of doing that is that the change method now becomes async whenever you call it across actor, which sometimes is fine, but sometimes maybe it's not. It depends how much work you're doing in this change method. Another way, which is new in Swift 6, we introduced a new log type. We call it mutex. It's part of the synchronization module, and it's really good in how it expresses the logging pattern. So instead of the usual lock and unlock methods, we have a with lock, and the mutex contains the value it's protecting. So you can see instead of the usual pattern, which I will complain about on the next slide, you can do state with lock, and the state itself is sendable, right? So you don't have to reach for unsafe, please compiler, trust me, this is guaranteed to be correct, right? So great type, don't shy away from using mutex as locks when the situation is appropriate, when you're doing a very quick change, when you're doing a counter or just flip a bit or very minute small operations, mutexes are totally fine, right? When you're doing more work and maybe you're suspending in the meantime, when there's a lot of things involved, business logic, you probably want to do an actor. For very minute small things, mutexes are totally fine. So don't shy away from one or the other. They both have the rightful place. Now, here's a pattern I want to warn you about, because this is what we would gravitate to before Swift concurrency, or ever, the early days of Swift concurrency. You would maybe apply a unchecked sendable conformance to the container type. This effectively turns off the compiler, warning, erroring, preventing you from doing wrong things. So you're on your own. And then you're using some kind of lock, doesn't really matter what lock type, using this lock, and this lock is separate from the value. So you always have to remember, state is protected with this specific lock. Maybe you have multiple locks, and different locks protect different parts of the state. It can get very complicated. And as you can see here, you can make mistakes. You can still mutate the state.change here, and you forgot to use the lock. The compiler didn't help you. So avoid this pattern as much as possible. Avoid generally unchecked sendable. When you're reaching for that, always take a step back and think, well, can I express this another way so I do get the sendable checking that the compiler gives me, right? So be wary of that. So an interesting part of Swift 6 adoption is that it's going to take time. Neither is Swift 6 the last and complete version of concurrency checking. We will keep improving it. And in the same way, the adoption story isn't complete yet. It's basically the beginning of all the libraries and ecosystem adopting Swift 6 and us going through all of this together. So there's a fantastic website, Swift Package Index, where under the Ready for Swift 6, you can track all the tracked packages in the index and how they're doing with their Swift 6 adoption. It's very interesting to have a look at. And, we hope that this line will increasingly go steeper and steeper up. So it would be nice to look at. Notable Swift 6 ready packages. So Hummingbird just recently released HTTP framework server. The 2.0 release is 6.0 fully enabled, I believe. I know that Swift gRPC and a pre-release is also working on being Swift 6 compatible, and we have a number of SSWG, recommended libraries like Service Lifecycle and a few more that are Swift 6 compatible already. Again, if something isn't Swift 6 compatible, it doesn't prevent you from using it yourself, but it's this going through the process together and gaining more confidence into our libraries. And I believe that Vapor is also on track for adopting in the next major release. Okay, so this was a very, very quick run through. Again, the primary thing I want you to remember is to check out the migration guide, download Swift 6, give it a go, enable the 6 mode. If you have any questions, reach out on the forums, report issues on GitHub. By that I mean Swiftlang GitHub, or the migration guide as well. If you want some more recommendations, patterns, if you feel you have something to contribute as a pattern, please help us out, and we'd love to hear from you. And we can take some questions about anything I talked about here and more.
Thank you, Conrad, for the presentation. We have a few questions, not so many, but we have a few questions in the comments. One of them is from Ali. Why can't we use dispatch.main to access the main actor isolated variable? Or is there another way to ensure that non-async parts of your code can remain?
That is a slightly confusing question because dispatch main is specialized to be aware that it's actually main actor. So I would ask you to paste a snippet, maybe on forums or somewhere, and we can look at why exactly what isn't working for you. Because dispatch main we specifically specialize.
Yeah, if you have a dispatch queue, then instead of accessing dispatch queue main explicitly, if you use it store the variable and then access it that way, then of course the compiler can't know.
I will call
I guess
other
I was
member.
thinking. Yeah.
Go ahead. Sorry.
I guess I was thinking about the closure style. You do the dispatch main dot async. This is aware. You were thinking about what pattern?
So many times people use dispatch queue.main to offload async work. And I believe the compiler is still aware, but if you store dispatch queue.main in a stored variable in a variable and then try to enqueue it on that variable, then the compiler is aware.
I see. I would recommend bringing that up on forums. Maybe there's a pattern we can recommend. There's tools including assume isolated. So you can say main actor assume isolated. You can store closures that are main actor, right? You can store the closure with a specific isolation as well. Maybe there's some tricks we can do to help you out.
I will call other member of the Swift server working group on stage. Simon, thank you for being here.
Hey, Simon.
Sven, thank you for being here as well to help answer a question. Maybe Sven, you can start with the next question from Ali as well. Do you think there is a parallel to Python 2 and 3, where only those starting new modules will use the Swift 6 feature?
I don't think so. It's very, very different. So the Python 2 to 3 break was dramatic, but you had to be whole foot in 3 or whole foot or both feet in 2, right? If you look at how we can mix and mash packages and targets even in the same package in different language modes, it's much easier to adopt, and we spent a lot of time on making that easy. So I don't think it's a big break scenario like this.
I'd like to add something to that, in that Hummingbird 2 already supports Swift 6, but at the same time, the same code, the same library works just fine with Swift 5 as well, including Swift 5.9. So you don't even need a Swift 6 compiler to run the code.
Right. Fantastic.
Do you see a risk that some, or maybe even a lot of packages will just never move?
Well, it might be the case, but I do hope that actively maintained packages, you do it for yourself, really. You do it for yourself to make yourself more confident that you don't have bugs, right? So you're not really preventing people from using your package if you never update. But so I don't think we're gonna have, no one can update because there's one package that never moved. The rest of the ecosystem can keep moving.
I feel like when people talk about it, they often see all the warnings and having to deal with them as a chore, and they don't see the benefits as much. I don't know why that is. I guess because the warnings are in your face, right, and the crashes aren't. They are sort of disconnected from what you're doing. But I think it's really worth
question.
Emphasizing that what you're gaining there.
Yeah, it's not that if you're getting these warnings or errors, you have bugs, right? It's not that, oh, it's fine. No, it's not fine. You just were lucky.
Yeah.
So, and I totally emphasize with some projects enable complete checking, and they have 20, 30, 50 errors to check out. But a lot of the time, we did some, we migrated some projects as well. A lot of the time, you start fixing one, and then, it's just the same thing that happened in 50 places, and it's not as bad as the first compilation may make it look like.
through
I
the
think
first.
having warnings there are also a risk to your project, because yes, it could be fine for like months, but then you
Right.
could get this weird obscure error that takes you like ages to debug. So it is a risk.
Yeah.
So people should definitely be like trying to get to the root cause of those errors or warnings.
Yeah, it's much more debug a compiler warning an error than spending a week hunting down a weird edge case. So yeah.
Yeah, particularly if that edge case is in production and you're under pressure.
Yes.
So Alice, thank you for answering the question. We'll go back to the use case and raise it on the Swift
Oh,
forum.
yeah, thank you.
Thank you, Ali.
And Tim was saying that Vapor 4 is already Swift 6 ready. Cool, fantastic. That's great.
Question from Onza. What do you recommend for package that still need to support 5.9 or 5.10?
Try to make source code. So I guess it depends. What we've been trying so far with some SSWG projects that I work on, like tracing, etc., is to have the same code base, but with enough if def Swift 6, if compiler 6, you can keep the same code base happy. A lot of the times, the complete concurrency checking in 5.9, 5.10 will be the same as the 6.0 mode. Sometimes the 6.0 mode is smarter, right? We just talked about sending non-sendable values. So it depends where you want to set your goal. You might want to say, okay, for complete checking, please use Swift 6, or you set the stack for yourself, right? You may want to aim for that. I don't have a concrete answer other than try to triangulate what works for you. At least with SSWG projects, Neo and other libraries, we always support 3 latest releases. So this would be 6, 5.10, 5.9. So this is what I would expect from majority of libraries to support.
Any experience on your side, Janice, Sven, Simon?
Not recently. So there's a couple of new projects, which obviously if it's completely new, then you can just start with 6, in which case you can just start with the Swift 6 language mode.
Mm-hmm.
Jalil, it's not a question, it's just a statement. Sometimes you fix your code or you enable Swift 6 and you realize how bad your code was. Yes.
Yeah.
I've been there too.
Yeah.
Mm-hmm.
Absolutely.
So
we caught bugs in the standard library ourselves. So yeah, absolutely.
Any other question? Please feel free to send us your question. And Sven, you're asking a question.
Mutex example. Let's see.
Yeah, I might have misunderstood, but I think if you bring up the slide on the right-hand side, the two examples at the bottom. One was converting to an actor, the other one was using a mutex. And the
do they still have an actor there?
Yeah, I think that's...
Oh, yeah. Let's see. 1 second.
Can you bring the code back on the screen?
Is that it? You're right. Yeah. This example? Yeah, right-hand side.
Can you share your screen again so I can show the screen?
Oh, wait. I need to do one more click. Sorry. There we go. Here?
And no, right now it's the StreamYard view, not the code.
Isn't it?
Right. Yes. Like this.
Is it okay now?
Yep. So is this the code you're talking about?
This totally should be a class here. Yeah. That's right.
Okay.
Cool.
Thank you.
Sorry, my mistake.
Any other question? Write them in the comment right now. As I said before, I will add all the links from Yuta's presentation and from your presentation in the description of the YouTube video. And of course, the YouTube video will stay online for the foreseeable future on YouTube. So share the link if you have friends or colleagues that could not make it this morning or this evening, depending on where you are. Don't hesitate to share the link, and the replay will stay available. There is no more question. So looks like it's time to say goodbye. Thank you, Yuta, for the incredible eye-opening session on WebAssembly, Wasm, and Swift. Thank you, Conrad, for this update on Swift 6, and Janice Van Simon for helping answering the question we had today. There will be a fourth meetup probably next quarter, so beginning of next year, January. The date is not fixed yet, but we'll work on
we
that.
Of course, also have the conference coming up in a week.
And
so,
yes, that's maybe I can show that again. And we are going to meet next week at the server-side Swift conference in London, Thursday and Friday next week. So if you can attend, you can have a 15% discount with the code SSWG Meetup. And many of the Swift server working group member will be there. And we expect awesome conversation and networking during this conference.
Yeah, the talks look really good.
They sure do.
Thank you, everybody, and have a good evening, a good day.
Thank you. Goodbye. Bye,
Bye-bye.
everybody.
Bye-bye.
Thank you.
Thank you.
Bye.